So this is the preheating chamber, fuel efficiency improvement system by using the preheating mechanism. So this is the silencer pipe. It goes to heat the chamber and it will be going to here. This is the exhaust. Then this is the atmosphere air. Here coming the atmosphere air. Then this tube goes to the carburetor. Here you have to connect the carburetor. So that time the shut the piston. Now normally without connecting this means the atmosphere will be going to the carburetor. Now we are connecting this tube that the preheated air. This is the preheating chamber. So the box will be heating for running for 15 minutes. Now also it will be heated. It will be heated. So that then the air will be going here. It will be preheating. The air will goes to the carburetor. So now the air will be going. Heated air means the burning ratio will be increasing. Before the atmosphere air time fuel will be burning at 70% only. Now the preheated air is going inside means 75% fuel preheating is now it will be fuel is burned up to 85%. So the 10% of fuel burning extra by using this preheated air. So that time the efficiency will be improved. So that will be drawing a graph and we have to prove it. Okay, we will first of all we will explain that component details. So this is the engine, Euro Honda engine, 100cc petrol engine, 4-stroke engine. Then this is the gear rod. This is the chain drive mechanism for transmission. Here you go to take the tachometer reading for the RPM. Then this is the scooty wheel with the drum brake, normal scooty wheel. Shaft 10 diameter shaft, bearing 6202 ball bearing. So this is the preheating chamber, 7 inch into 7 inch. Sheet metal, 1 mm sheet metal preheating chamber. Before you go to take a reading of without preheating reading. Now this will be heating. Go to take the reading here. After that, you have to connect the tube here. So now the preheated air is going here. So this is the off wire. So now you have to take a graph. Now take a fuel efficiency graph. The fuel efficiency graph, we need a burette, tachometer and stopwatch. 3 things we needed. So this is the burette, 10 ml, 20 ml, 30 ml, 40 ml. Like that it will be reading will be there. Then this is a time versus speed versus time graph. Speed, time, fuel is constant. Fuel 10 ml. So you got to remove this tube too. Then you go to this tube is connected to burette. Here you go to remove the tube and you go to connect this tube to burette here. You go to connect the burette here, petrol tube. So now without preheating means you go to remove this tube. Put it on the ground. First you go to take here, first gear, 50 RPM. Then first gear, 100 RPM. Second gear, 150 RPM. Second gear, 200 RPM. Third gear, 250 RPM. So you go to like that way, you go to take a RPM. RPM is first you go to put the first gear here, you take a tachometer here, you go to put on here 50 RPM. Slightly you go to raise that one, you want to maintain the 50 RPM. So now you go to start the fuel from the 0 to 10. How much time it will be running? You have to take a stopwatch. 10 ml fuel, how much time it will be running on the 50 RPM without preheating. Suppose it will run on 2.5 minutes means you go to that down the reading. Similarly, first gear, same one, you go to raise the accelerator, the 100 RPM will come. So that time also same 10 ml, 10 to 20. 10 ml fuel, how much time it will be running? So now it will be 2.1, 2, like that it will be decreasing. So similarly, you go to draw a graph like that way. Second gear, 150 RPM, second gear, 200 RPM, third gear, 350 RPM. The 5 reading is enough. So this is for normal engine. without preheating engine. This is normal efficiency of the engine. Then you go to connect this tube. Now that this reading taking time, the preheating chamber will be heating. Now you go to same reading, same 50 rpm, same 10 ml. You go to take a preheating, you go to connect this tube and you go to take a same reading means now before it will run at 2.3 minutes means now it will be running at 2.5 minutes. Like that way it will be little bit increasing will come. So this is the preheating graph, preheating. So this is the difference. So the difference is 5 to 10% will be there. So this is the fuel efficiency graph. So you go to draw like that way, you go to take a reading from the different gears and 10 ml fuel. The fuel is constant, 10 ml fuel from the burette. So take a stopwatch to start the time and close the time. You go to accelerate that one constant speed. 50 minutes you go to maintain the one person is maintaining the speed, one person is putting the tachometer, one person is taking a burette to 10 ml fuel. So 3 person needed to take this reading. So after that you go to draw a graph means this will be average reading. You go to take on each and every reading you to take 2 or 3 readings. 50 rpm means 2 reading. 100 rpm to take the 2 reading and average it. Average it you go to calculate here. So similarly you go to draw a fuel efficiency graph by preheating method. So this is the concept of fuel efficiency improvement system by using the preheating method. So in this method up to 5 to 10% of fuel efficiency will be improving. So if you want to engine efficiency mean you go to couple here to brake drum or load test means you go to run by the engine efficiency also it will be increasing. So in this setup only it will be done by the fuel efficiency graph only. So this is the fuel efficiency improvement system by using the preheating method. Exhaust preheating method. This is exhaust gas is goes to preheat the chamber, it will be going to here. The exhaust gas will be going here. This is the atmosphere from here to goes to the carburetor. Thank you.